Hello, everyone. Welcome to today's webinar, What is API Testing and Are You Doing It Right? My name is Chris Colosimo and I'll be moderating today's webinar. Before we get started, I just want to do a quick reminder. Parasoft will be at Star East this May 3rd, where we will be unveiling some new technology, and we're excited to get this into your guys' hands. This will be a virtual conference, so if you have the time, go ahead and take a look at this link and register for free, and you'll be able to watch the presentation and see what we're announcing. Again, the title of today's webinar is What is API Testing and Are You Doing It Right? Today we will be discussing what APIs are and how to build a solid API testing strategy. I'm joined today by Thomas Moore, our Senior Technical Consultant. How are you doing today, Thomas?
I'm doing pretty good, Chris. Excited to show everybody the fundamentals of API testing today. So as he said, my name is Thomas Moore. I'm a Senior Technical Consultant here at Parasoft. My expertise comes with helping organizations adopt and basically get started with API testing, specifically with having a CI/CD pipeline in mind. So let's go ahead and get started with the big questions here. So what are APIs? The general definition for an API is a programmatic interface with one or more public endpoints to an application that's been deployed on a network. Now, this network can be over the web, it can be a hidden network that's company specific, but what we're really looking for is something that you can actually access using some sort of endpoint. Now, with most APIs, there are a few common practices, one of which is that they usually communicate using REST or SOAP over HTTP. And the other is that they are usually in either JSON or XML format. Now, these are most common. There are some deviants, but this is the usual ones that we see. So this is a nice definition for APIs, but it doesn't really get a picture in your mind. So let's imagine that we have a restaurant. Now, this restaurant is going to be an example of an application. We have a number of consumers coming in. They're going to be ordering food, which is the services that they're going to be quite literally consuming. And we have our backend or our chefs preparing those services for our consumers. So as I said, we have our diners in our restaurant, which are going to be our consumers. We have our waiter, which is going to be the transport layer. In our case, it's going to be HTTP. And then on the back end, we have our chefs, which are going to act as our application server and provide those services for us. Now, tying everything together, what we have is our API, or our menu. Our menu in this case is going to have a list of all the services that we are going to be providing to our consumers, and it's going to have brief descriptions or different ways that they can be ordered. Now, why do APIs matter? What we want to be able to do is to illustrate why APIs are important to users. Now, in recent years, there's been this notion of the API economy. Basically, what it is it's a description of how businesses survive and thrive on the existence of APIs. Now, over the past few years, we've seen a huge growth in the number of publicly available APIs uploaded to the programmable web website. We can see here since 2013, there's been an increase in almost, 8,000 APIs that are available to users. I just checked this last week, and they're just about to hit the 20,000 API mark. So we can see that the existence and development of APIs is not slowing down. In fact, the increase has been linear for a number of years now. So basically, the whole world is going to this point where everything is going to be driven by APIs. So again, this is a nice broad overview of API economy, but why does this matter to us, the end user? Let me give a few examples, and each of these is going to be more and more grand in scale. So starting from the bottom, let's say I'm running late to work. I haven't had time to have my breakfast. So what I do is I go onto my Starbucks app, and I order ahead, and I'm going to order my usual double chocolate chip frappuccino. Now, for those of you who don't know what that is, basically it's a drink that has no coffee in it because I don't like coffee. But what happens if the API that the app is built upon sends the wrong drink ID to Starbucks? Now, not only when I get there, am I going to be unhappy that my drink tastes like coffee, but I'm also going to have to wait a few minutes to get my drink, all the while unhappy. The store is going to have to eat the cost of the drink that they're making, and then they may have to go through a little bit of brand name loss as I badmouth that particular Starbucks and go to a different one instead. So let's go ahead and bring this up one notch. Let's go to a medium scale. Let's say we have a business owner, and this business owner is about to prepare stock and order stock for a weekend rush. Now, they've had a busy day, so they go on a website to their local bulk supplier, and they start filling out their application for a stock order. And at about 11:50, they begin this process. Now, they start ordering all their information, and before they click submit, the clock ticks over to midnight. And when they click the submit button, the API, instead of taking the start time of when they started their order, is instead taking the current time. What's going to happen is they're going to get their shipment a day late. So they're not going to be ready for the Friday night rush. And what's going to happen is this business owner is, instead of being able to take in all this Friday night business, is instead going to lose the potential profits that would come with having an on-time stock order. Let's take this one step higher. Imagine we have a business whose sole being relies on the existence of an outside API. Here we have the Uber app. Uber's entire business structure runs off of the Google Maps API. If something happens to that Google Maps API, the Uber app is absolutely useless. So let's say, for instance, that the Google Maps API, for some reason, switches latitude and longitude. What's going to happen to the Uber app and Uber drivers and the company in general is they're going to suffer a dramatic loss in profits over the day and a huge loss in brand name recognition. Now, each of these three examples has some sort of risk associated with it, whether it be small-time risk of me being annoyed at this particular Starbucks store to the catastrophic failure of a business model. What we need to do is we need to have a solid testing strategy in place that will go ahead and give us the assurance that we need to continue forward and deploying into production. Now, up until this point, I've been talking about API tests here on our testing pyramid, and I'll go ahead and go further into that. So what organizations usually do is they'll have a testing strategy in place that will have multiple interfaces into our application under test. Now, the three examples I gave, one on my cell phone, one on the web where the user is ordering their stock online, and one being a more direct API where Uber directly interfaces with the Google Maps API. All of these actually leverage APIs. So APIs is the most important part of this application testing strategy. But what we see is that there's actually not a lot of tools available to test this API layer. And on top of that, we do have other tools that may or may not interface with each other on the other layers. So what we do need is to have one central place to do all of our testing. Parasoft SOA Test is an industry-leading API testing solution that will simplify the often daunting task of creating meaningful API tests. So as we test across these different interfaces, APIs, as I said, will often be the most critical. And what SOA Test can do is not only leverage existing mobile, existing web tests, but we can also use API tests and database tests, and I'll get into that in more detail a bit later, to verify that our application is as robust as we need it to be. So that's an example of API tests, but then comes the question, how do we actually test an API? So this may look a little bit daunting at first, but there's 6 basic kind of tests that we want to leverage in order to test APIs. Now, each of these tests actually builds upon the last. So while this may seem like 6 different tests that have a lot of things associated with them, we can actually reuse test artifacts to make each subsequent step easier. So let's go ahead and dive into these individually. So service definition tests. What these will do is they will test our API, our menu, to make sure that we don't have chicken, rude, and unreasonable. What these will do is they will validate the semantics of our API, the structure of it, make sure that it's actually machine consumable. So is our API semantically correct? Is the service valid? Does it meet any operability standards? And most importantly, has the service recently changed? Now, I'll be getting into the changes a bit later, but I do want to emphasize it here and we'll keep it in mind. So let's see how Parasoft can simplify the creation of service definition tests. All right, so here I have my SOA test application here. And what I'm going to do is I'm going to lay the groundwork for my further testing. So here what I'm going to do is I'm going to go ahead and add a new test here. And for this test, I'm going to leverage a WSDL service definition. So what I want to do is I want to specify a specific WSDL here and create tests to validate and enforce the policies on said WSDL. So what I have is a number of tests that were created here. So I have my schema validity, my semantic validity, and what these will do is these will make sure that the API is machine readable and able to be consumed by our clients. We have our interoperability here, which will make sure that we meet some standards with our API here. And finally, we have our WSDL regression. Has anything changed since the last time I ran tests? Now, what we want to do is we want to make sure that we meet these standards. And if any of these standards are not met, then we have a problem. So as you can see here, I have some interoperability problem with my WSDL. I may not want to go forward with testing until this is resolved. Now, because we injected this in here, I don't really care about this error being thrown, so I'll go ahead and discard it for now. But as you can see, what service definition tests will allow us to do is provide a solid foundation for our test resilience. I want to make sure that the concrete layer before I build my building is solid before I create my structure. So let's take this up one level of our testing groups here and talk about component tests. Now, going back to my restaurant, what I want to do is order every individual entree, dessert, appetizer on my menu. And when I get it, I want to receive it in a plate. I want it to look good. I want to make sure that it tastes good, that it's cooked correctly. My forks are on the left, knives are on the right. What I don't want is to receive food on a clipboard that looks like it was overcooked and there's some kind of onion and nastiness sprinkled over it. I want to make sure that everything looks like it does here on the left. What component tests will allow us to do is test the individual pieces of a service, looking for a few things. We want to make sure that our request and response payloads are well formed. We want to make sure that we get the expected response status. Is it a 200 success? Is it a 500 internal server error? If we do get an error, what do our payloads look like? We want to make sure that we have the correct error messages. We want to make sure that we meet some baseline criteria. And finally, we want to make sure that our response is received within an expected time frame. So let's take a look at how I can create component tests within SOA test. So again, I'm going to go ahead and create a new test here. And again, I'm going to use the same WSDL option here. And this time I'm going to create functional tests. Now, what this is going to do is it's actually going to parse my API, and it's going to create one test for every individual service that's contained within my API. So let's see what happens when I run this. Some of my tests passed, some of my tests succeeded, or sorry, some of my tests failed. What we want to do is we want to go into each of these tests and verify, okay, if I got an error, what does my error message say? And does it fit the criteria that we want? So for example, if I take a look at my response for add item to cart, no book with the ID of 0 was found. Now, when it created all these tests, it did have some starting data in it. So in the case of add item to cart, it's expecting a number in its requests. So we give it a starting value of 0. If there's no books with the ID of 0 in my bookstore service, then I'm going to get an error. So this looks good to me. It looks like my API is helping my service respond in the way that I would expect, so that I know I can continue forward with the grander scope of my testing. So as we can see, what component tests will allow us to do is validate that the individual resources will work as expected. Basically, component tests are unit tests for QA. So now that we have the individual components, we know that each of these work individually. What we want to do is put these together into a group, our scenario tests. Now, in our restaurant example, our scenario test would be I arrive at my restaurant, I get a table, order my food, get my receipt, pay for my meal, and leave. But what happens when we get our check, and instead of the table for 2 that we had, instead we're getting a check for the table of 20 that's just across the aisle from us? What we want to do is we want to make sure that the data that we're being fed matches with the data that we are expecting. Scenario tests allow us to do this by reusing our existing component tests to make sure everything works in a scenario. So when we combine our APIs into our scenario, we want to make sure that they all work together. We want to drive our tests with some starting data. We want to use response data to feed into subsequent requests. As I was saying, when I get my receipt, I expect to get my food back, not their food back. And we want to optionally leverage startup and teardown tests. All right, so let's see how we can leverage scenario tests. So here I have my existing component tests. What I want to do is create scenario tests from here. So what I'll do is I'll go ahead and make a copy of this test here. And I already have the building blocks for what I need. But instead, what I want to do is I want to pick and choose the individual components that are going to be used to test my particular scenario. Now, in my particular scenario, what I want to do is I want to search for an item. So I'm going to search for an item by title. I'm going to add that item to my cart, and then I'm going to submit my order. Now, this would be a similar workflow as like ordering something on Amazon, for example. So let me go ahead and get rid of the tests that I don't need and switch the order of my tests here. And now I'm just about good to go. What I want to do is I want to take this particular test and I want to supply it with a book that I'm searching for. So for example, my favorite programming language, I'll go ahead and put in Java here. And when I run my tests, I should expect to get a book back with the title keyword of Java. I would add a book
on Java into my cart, and then I would submit that order. So let's see what happens when I run my test. All right, looks like my test has a breakdown somewhere. What happened? So it looks like I'm still getting my note, or my book with the ID of 0 is not found. What's happening is I'm not passing my response data into subsequent requests. So let me go ahead and fix that. If I go into my test 2 here, we'll see that I have the option of specifying my item ID, which is where we're getting this 0 book ID not being found. What I want to do is I want to pull my response information from the first test and feed it into my second one. To do that, let me go ahead and switch this to parameterized. And what this is going to do is it's going to pull the response information that we received from my first test. In this case, I'll pull the ID from my first book that was returned here and leverage this to fuel my tests. So once I have this, let me go ahead and run my tests. OK, 3 out of 3 tests succeeded. Let me go ahead and verify, using my traffic here, that the submit order test succeeded. And if I take a look at my traffic, my success criteria is false. Now, what happened was exactly like we were doing with test 2. We weren't passing the response data into our subsequent requests. So let me go ahead and fix that. All I need to do is specify a card ID. So once again, I will parameterize this value using a data source wizard. And instead of looking at the existing message for test 1, I want to look at my message for test 2. I want to pull out my card ID. All right, this is looking good here. And because I don't want to manually look at my traffic every single time I run this test, let me go ahead and also add an assertion that says, is my success message true? So taking a look at my configuration here, I don't want this to be false. I want this to be true. So now, when I close all my tests here and rerun, 3 out of 3 tests succeeded. And I know that my assertion provided a true response because I did not get any new information in my quality tests, my error review here. So what our scenario tests allow us to do is understand the defects that are introduced by combining different data points together. Now, there's another way I can illustrate this, which is working with a customer. We had a service that returned dates and times, and we needed to pass that date and time into a subsequent request. Now, when we got this date and time format back from one service, our date and time format also included milliseconds. When we passed it into our subsequent request, we needed to make sure that we had only down to seconds. When the request was passed into our service, we ended up getting an error because the date time format was incorrect. The only way that we were able to tell this is by leveraging scenario tests. If we had stayed with our happy path component tests, we never would have found this defect. So now that we have everything working here, let's take this one step higher and go into performance tests. Our restaurant is ready to go. We have our meals being prepared correctly. We have the correct receipts going to the right customers. Now it's ready for Friday night rush hour. What we don't want is a bunch of people standing out on the sidewalk waiting for a seat to get their food. Instead, what we want is a nice, orderly area where people can get their food, have a nice time, get their checks, go home happy. To do this, we want to utilize a combination of component and scenario tests that we've already created to validate our application's SLAs and the timely performance of our application. So leveraging Parasoft SOA tests, what I can do is add our tests into performance testing software. So what I'm going to do is add a new performance test using my existing SOA test artifacts that I just created. And I want to leverage my scenario tests here. Now, what I can do once I have this is run my test. So for example, I want to run this under a steady performance load of 4 concurrent users. And because I don't want to keep us here all day, instead of running this test for 10 minutes, let's go ahead and run this test for 10 seconds. Once I have this, I can go ahead and execute my performance test. And I'll give this just a moment to execute here. And while this is going through, we also have a view into a graphical representation of our test execution here. And it looks like we have succeeded on all of our SLAs. So we have a constant stream of about 157 hits per second onto our service, which is much higher than the expected SLA of 10 hits per second. And if I want to take a more detailed look at the average execution time of my tests, looks like I'm staying right about the 12 to 15 millisecond response time, which is excellent. This is exactly what I want to see from my application. Now, in addition to steady load, we also have some other performance scenarios that I could leverage. But in the interest of time, let's go ahead and do a high-level overview of what performance tests do, which is validate that our application can behave under the various different types of stress that I could put my application under. So once I have my performance tests set up and ready to go, let's take one step to the side. Instead of going up this ladder, let's take one step to the right and look at security tests. Now, what security tests will allow us to do is check for any existing vulnerabilities that exist within my application. So if, for example, we had one customer come up to our waiter and say, "Hi, I'd like a burger that drops the entrees table in our database," first of all, our waiter is going to take a step back and say, "Wait, what?" Second of all, what our malicious customer here is doing is attempting to do a SQL injection into our application. What they want to do is make sure that our restaurant can serve nothing but appetizers, desserts, and drinks. This is not what we want. We want to be a full-service restaurant, just like we want a full-service application. So what we want to do is we want to utilize our existing component and scenario tests to kick off different kinds of penetration and security testing. So going back into SOA test here, I have a security test that's pre-built for us. So let's take a quick look at this. And what we are doing with this is leveraging our existing component and scenario tests to kick off different penetration tests. Now, again, in the interest of time, penetration and security tests take a long time to execute due to their very nature. But I do have a report ready to go. And this was taken from a different test that I had. And what this will show us is in this particular application, we have some errors that we need to solve. Now, in this case, we have some clear text submission of passwords into a banking application. So if somebody malicious wanted to sniff my traffic, find my username and password, they could log in, withdraw all the money, deposit it into their own accounts. So I need to fix this issue with my application and continue on once it's strengthened in this way. So this is an absolutely integral part of our testing strategy because security tests will allow us to safeguard our application against malicious behavior and getting rid of the vital information that we need. So taking all of this into account, let's go one step up the ladder once more and talk about omni-channel testing. Now, what omni-channel testing allows us to do is test every single external entry point into our application to allow and ensure appropriate behavior from every single possible angle. Taking our restaurant into consideration once more, our diners don't always come in, sit at a table, and get food. Instead, they might look us up on the website, They'll order food there, they'll get takeout, they might have a drive-through that they get food from. We need to make sure that each of these different operations, we receive the same burger. So again, what SOA test will allow us to do is, say for example, I have my restaurant's website, and I want to access that via my mobile application. I want to look at my menu. And I say, hey, I want this burger. So what I'll do is I'll go into their actual website. I'll order my burger. I'll drive to my favorite local restaurant. I'll make sure that that burger is actually on their menu, in this case, the API. And then finally, I can go ahead and eat my burger in peace. Now, one step up, what SOA test will allow us to do is pass this information from one service to the next. I take my burger from my mobile view of the menu, pass it into my website. I take my reservation number, I go to my restaurant, sit down at my table, and this happens to be a fancy restaurant that has a view into the kitchen, so I can actually see my chefs at work. I can see my database working with MySQL and NoSQL calls. Now, this is just one example of an end-to-end test. What omnichannel testing is all about is ends-to-ends testing. Every single permutation of this that we can possibly fathom. So omnichannel testing with our restaurant here will allow us to comprehensively test our application across multiple interfaces. All right, so bringing everything together, what kind of API tests are there? We have our service definition tests, which are tests against our service definition itself. We have our component tests, which will allow us to test the individual operations that are present in our service definition. Our scenario tests, which put our component tests together with respect to each other. Our performance tests, which will leverage our component and scenario tests for compliance to our SLAs. We have our security tests, which again will leverage our scenario and component tests to test our application for security vulnerabilities. And our omnichannel tests that will test every entry in our application from ends to ends. Now again, these are the 6 kinds of API tests that I've highlighted here. There are absolutely more. We have negative tests, positive tests. I'm just not going into detail for those here. These are the basic framework which will allow you to get your application up and running. By all means, leverage the other API tests that I haven't posted here. So there was one thing that I talked about earlier that I said I would put specific emphasis on, and this is managing and mitigating change. All these tests that I have are great. They function perfectly. But what happens when my menu changes? If I add or remove certain menu items? What we want to do is bulletproof our application. We want to make sure that our tests will be able to adapt to change quickly. And change can take many forms. For example, we can add or remove elements from our APIs. There can be a fundamental code change that affects our data format. Or as organizations go forward, they may be going towards a shift towards microservices. So from our restaurant example, for microservices, we take our full service restaurant, and instead we break it into 3 separate restaurants. One that serves breakfast, one that serves lunch, one that serves dinner. So how can we manage and mitigate this change within SOA tests? So what I have here is a change template. And what this does is this maps any differences between my old menu and my new menu. So for example, I have this one operation here that introduces some changes to my application. We renamed some elements, we added some elements, we took some out. And what we want to do is we want to have a nice way of going between one and the other. So a test allows us to do this and automatically update our test cases to account for this new change. All right, so I've talked about what API testing is, how we can do API testing. Are we doing API testing right in our individual organizations? Now, what we want to do is make sure that any technology that we leverage for API testing will allow us to simplify that process. We want to have one consolidated, centralized ecosystem where we can kick off our various testing techniques, make sure that we can do everything that we need to do. And to do that, there are some things that we need to keep in mind, some questions that we have to ask ourselves before we go forward. For example, what environment is our application deployed in? Do we have access to that environment? If not, what we need is a template that will allow seamless execution of test artifacts between environments by switching a simple flag. We need to ask ourselves, what kind of services are we testing? If we're testing the wrong services, then all of the API tests that we're creating are for naught. We need to make sure that we're testing against the correct service. What do we want to achieve with this test? Many organizations are using requirements traceability software like Jira to test, hey, what are my existing requirements? What we need is software that will allow us to plug into those requirements traceability frameworks, make sure that we're actually meeting our expected requirements. And also, what is our expected outcome? If we need a test to succeed, does this test succeed? If this test needs to fail, does it fail? Does it fail correctly? We need to make sure that we get all of this information right. Furthermore, what we need to do is we need to leverage our pre-built tests for reuse. As we can see what I did earlier, I leveraged my existing component tests to create my scenario tests. We also need to be able to plug our existing API tests into a CI/CD pipeline with test automation. And we can do that through different CI infrastructures, Jenkins, Bamboo, TeamCity. So I think that wraps up for what I wanted to talk about. Chris, do we have anything further that we'd like to talk about?
No, that's excellent. It's a lot of information. Why don't we take a second and move into Q&A here. It's interesting, Thomas, there's actually a fair bit of discussion going on here around the order of the tests. So let's say this. I'm going to try to summarize these into one question. In what order should we execute the different types of tests that you mentioned?
So the order that I presented them here is actually the order that we want to execute our tests. So starting from the bottom, we have our service definition tests. If our service definition tests fail, then none of the other tests hold as much weight as they should. We need to make sure that we have the solid foundation before we build up upon there. Then we have the component tests, which basically test the individual components, make sure that they're working as expected. Scenario tests build upon that. Performance and security tests build upon that. And omni-channel tests build upon that. So we want to start small and then build upon.
Excellent. If I could just add one thing to that, I think that what really makes that powerful is that change thing you showed at the end. And the idea is if we're using our component or scenario tests to form the backbone of all the rest of our testing strategy, then being able to rapidly mitigate change at the scenario level affects our security, performance, all the rest of the tests, and everything is just kept nicely in sync.
Absolutely.
So I have a question here that said, is Parasoft a tool? I've got a couple of questions that are like that. Let me take a swing at this, and you tell me if I did this right. So Parasoft is a toolbox. Right? It provides the ability to create API tests at multiple layers of your application, from the very high level, like Thomas showed with the web and the API, as well as having tooling that allows us to investigate the middle. It is one consolidated workspace that you can use that doesn't require a lot of heavy installation. You cool with that?
Yes.
Okay, so I want to follow that up with some other questions that we have. Does it support REST API? Does it support microservices? I have a lot of does it support questions. And so the answer to all of you is yes.
Yes.
So SOA Test has the best-in-breed, industry-leading API testing solution. And what that means is that it was built from the ground up to simplify the process of creating API tests across the various message formats and protocols that exist in the industry. Not only do we support REST and SOAP and common XML, but we also support middleware technology like MQ, JMS. We recently extended it to support microservice technology, Kafka, RabbitMQ. It supports actually 120 plus message formats and protocols, even some industry-specific message formats like ISO 8583, Fix, Swift, all of those different things. So absolutely, it is a big toolbox, and yes, it supports those. And the techniques that you would use to create the various tests, given those different message formats and protocols, are identical to what you've seen Thomas do here today.
Yeah, building upon that a little bit, there's absolutely no difference between the workflow that I had here with creating tests from a SOAP definition and creating tests in a REST definition. They're exactly the same workflow.
Excellent. I'm going to actually read this question verbatim because I like the way that it's worded. I see you can kick off performance tests, that's cool. Can we generate load in the cloud?
Yes. One of the abilities that we added recently was the ability to create and kick off, what's the exact word I'm looking here?
Load generation?
Yeah, load generation machines in AWS. So all you need to do is provide the information to the load testing software, and you can go ahead and leverage those machines.
Excellent. Yeah, and those are available on the public marketplace there in Amazon. What else do we have here? How can we treat one scenario with multiple test steps as one test? And I think maybe the question that's being asked there is, if I have different things that I need to do, log in, get accounts, add new customer, verify customer, how can I treat that as one test? Let me take a stab at it first.
Yeah, I'm not quite sure I understand the question exactly. So.
I think it's one of those things that's fundamental to SOA test, but the idea is that inside of the test cases that Thomas was showing, one of the things that you would see is that all of the different clients that he was working with that were doing the different test steps lived inside of a test scenario. It is as a single file that stores all of the different information for what you're requesting, your assertions, so on and so forth. You can either put data right there in that test file, or you can externalize it with CSV, Excel, database, what have you. What makes this valuable is that single artifact can then be used to execute the test in an ad hoc way, or can be used as a part of CI and then communicated back to the development teams for defect reproduction. So yeah, it's one single file. And the other thing that he was showing with that Omni test that he was referencing was the ability to reference these test files in other test files, so that you don't have to reinvent the wheel every time you want to create tests. That
yes.
sound good? Okay. Let's see here. Oh, I saw this somewhere. Oh yeah, I think it was in chat. It said you mentioned test setup and test teardown tests. So how would those work?
Okay, so rather than showing those, let me go ahead and give an example. Say we're running tests, and those tests end up exercising our application in a way that changes information within our database. What we want to do with setup and teardown tests is basically use a few calls to clean up our database after we're done testing, so that it's back in the state it was when we started. If we don't do this, then it's going to end up creating dirty data, and then tests may end up becoming dependent on each other. And that's something that we really don't want in a grand environment, because you'll need to run 500 tests just to run this one test that we need to execute.
Excellent. This is just sort of a comment, and I like it. Somebody was asking, in our organization, we like to run the security tests prior to the performance tests to avoid surprises. Can we run, basically is asking, can we run the security tests before the performance tests?
Absolutely. So as I may have mentioned, I didn't really highlight it too much during the presentation. Performance tests and security tests go side by side. So you can execute those in any order you wish, but the important part is that they are there.
Yeah, I just add it as a part of that. I think that what's important is that both security tests and performance tests leverage your component tests. So it doesn't really matter in which order they execute.
Order is not important.
Yeah. They can even execute simultaneously. Question, can you please show us how security testing is done in SOA test? I would love to do that. If you click on that link there, software.parasoft.com/SOA test, you'll connect with us directly and we can show you a deeper dive demo on all of the different testing techniques that you saw today. So the question here is asking if you can pull API definitions from a specific location, like an API repository or a gateway, and then perform the different testing. You actually have to have the file.
You do not have to have the physical file. If you look closely at when I was creating my tests in the service definition and component test sections, I was actually using a website to create my tests. So what it did was it went online, it found the service definition that was up on the web, and parsed it there.
Excellent. And that way, if the whistle changes at the location, you immediately get the update.
Exactly.
Okay. Okay. I'm going to read this question, and I'm going to take a stab at it here. What if documentation for the APIs doesn't exist, right? What if the API is just presented to the client and there's no actual requirements? How do you build tests? Let me take a shot at this first. So building an API test from a service definition is just one of many ways that you can create API tests inside of SOA test. SOA test has the capability of building API tests from scratch by simply using the XML or the JSON, as well as being able to bring them together from recorded traffic. And on that, I would advise anybody who's available to attend our upcoming Starry's virtual presentation, because we're going to be unveiling some new technology targeted at just this question. How do I build an API test if I have no access to the underlying APIs or knowledge of them? And the answer is, hint, artificial intelligence. All right, so let's go down here. What level? Oh, so actually two people asked this question in a different way. So the question is, can we do UI testing? And what browsers can we do UI testing in? And then I'm not exactly sure what the third question here is, but yeah. So can we do web testing with SOA test and
yes.
And is it easy?
Short answer, yes. Longer answer, if you have existing Selenium tests that you don't want to recreate, we can go ahead and use those directly within SOA test and then build upon that with using SOA test to basically record and play back web scenarios.
Okay. Yeah, and a wide variety of browsers are available. Mm-hmm. Lots of questions here about microservices, which fills me with happiness here. I'm going to summarize them, but basically the questions are kind of asking around the differences between the API testing that we're seeing here and from a microservice perspective. There's some subtlety to it. Two things. The first thing that I would encourage you to do is to go to our website. Under solutions, we have a microservices section that really talks about the different, the buzz about microservices and different ways that we can communicate with them. We did recently just do a webinar on how to test microservices, but I think at a high level, from a SOA test perspective, it's no different. The tools and the techniques, what changes are the message formats, the protocols, things like that, and the ability to create isolation in microservices, either in a synchronous way or by using the queuing technology like Kafka, MQTT, so on and so forth. And there's a fair bit of service virtualization, which is a simulation technology that is designed to stabilize test environments during test execution. service virtualization becomes an important component of that, and it's a part of the Parasoft functional test ecosystem. Let's see here. I'm just going to do a quick time check here.
10:53.
So I've gotten this question twice here. It's asking about templates for performance and security tests. In both of those methods of testing, templates can be created. For performance testing, it's in the form of something called a scenario. And in a scenario, it basically describes what different users or threads are doing as they're executing, at what level, at what time. And those can be reused across different functional test scripts. For security tests, we have the ability to define which endpoints are in, which endpoints are out, what types of tests to do against the different endpoints, and so those templates are made available. So there's a question here about mapping different artifacts to each other. I think part of what you showed there was the change impact, which can map different versions. Now he was showing it for a WSDL. We can do that for RAML, OpenAPI, whatever definitions you have. There's also the ability to reference different test data in other test cases. So if you have like a complete transformation from a SOAP API to like an open API, it would be important to take the existing data and tools and assertions that you've used and migrate those over to the test. Okay, so I think we're good. Let's go ahead and wrap it up. So thank you, Thomas, for an excellent presentation. There's still a lot to this, but I think that this helps us lay the foundation for a solid API testing strategy and forge a sustainable path moving forward. Thank you, Thomas. Excellent job. And thank you, everybody who joined us on the webinar.
Thank you for inviting me.
Bye.